Students, in this video we will discuss the structure of benzene. First of all, we will discuss the old concept. We know molecular formula of benzene is C6H6. This is the molecular formula of benzene. It means total atoms are 12. All the 12 atoms in benzene, they lies in the same plane. And benzene has a planar cyclic conjugated system. So if we draw the structure of benzene, it is made up of a hexagon of 6 carbon atoms. Like we have 6 carbon atoms which have alternate double and single bond. We made the hexagon of 6 carbon atoms having alternate double and single bonds like this, and with each carbon atom one hydrogen atom is attached. With each carbon atom one hydrogen atom is attached like this here. Or we can make the structure like this way. Since in the benzene ring the pi electrons are delocalized, pi electrons are not static, they are continuously moving inside the benzene ring. ठीक है ना? So all the 6 carbon atoms, they will share the pi electrons. ठीक है? If at the one moment pi electrons are present between these two carbon, then in the next moment they will move like this here, and this pi bond is shifted over here, and this will go like this. ठीक है ना? So position of pi bonds are continuously changed. Okay, now we can represent these structures like this way. With the help of line structure, we can represent the structure of benzene, this one or this one. These forms. These structures, they are known as Kekule structures of benzene. These structures, Kekule structures. These two are equally valid resonance contributor. These two forms can be combined in the resonance hybrid, and the conjugated system is represented with the help of circle inside the benzene ring. So how can we represent the third structure of benzene? We can make the structure of benzene like this, and instead of making pi electron, we write a circle inside the benzene ring. Right? This structure of benzene is known as Robinson structure. This is Robinson structure. Robinson structure of benzene. All the carbon-carbon bonds are of 1.4 angstrom. Carbon-carbon, all the carbon-carbon bonds, they are 1.4 angstrom. That is between carbon double bond carbon and carbon single bond carbon distance. It is between carbon double bond carbon and carbon single bond carbon distance. Now students, all the carbon-carbon bonds are ऑफ इक्वल लेंथ, यानी इन केक्यूल स्ट्रक्चर में अगर हम देखेंगे तमाम जो कार्बन सिंगल बॉन्ड है इनकी लेंथ बराबर है. इट मीन्स देयर इज नो कार्बन डबल बॉन्ड कार्बन, नो कार्बन डबल बॉन्ड कार्बन, राइट, एंड no carbon double bond carbon, no carbon single bond carbon, right? All the carbon bond length are equal. Now we will see what are the drawbacks of Kekule structure. Drawbacks of Kekule structure. It means what are the limitations of Kekule structure. Drawbacks of Kekule structure. Kekule structures fail to explain. कौन कौन सी चीज़ें जो हैं वो Kekule structure की हेल्प से हम explain नहीं कर सकते. The first one, Kekule fails to explain that although there are 3 pi bonds which are present in the benzene ring. Benzene ring के अंदर 3 pi bond मौजूद हैं, उसके बावजूद benzene is less reactive. Benzene is less reactive. हालांकि बेंजीन रिंग के अंदर कितने पाई बॉन्ड मौजूद हैं? 3. ठीक है, बेंजीन इज लेस रिएक्टिव. द सेकेंड इंपॉर्टेंट ड्रॉबैक इज बेंजीन शो डुअल कैरेक्टर. बेंजीन मॉलिक्यूल शो डुअल कैरेक्टर. बेंजीन इट हैज डुअल कैरेक्टर. डुअल कैरेक्टर का मतलब क्या है? देखिए, इन द बेंजीन रिंग वी नो 3 pi bonds are there inside the benzene ring. ठीक है, which shows that it is highly unsaturated molecule. It is highly unsaturated molecule, right? So it can gives addition reaction. ये कौन कौन से reaction देता है? Number 1, it gives addition reaction. Addition reactions. But at the same time, it can also gives substitution reactions. Substitution reactions. It can give addition reaction like unsaturated compounds. ठीक है, at the same time it gives substitution reactions like saturated compounds. So it shows that benzene has dual character. ठीक है, it has dual character. Then the third important drawback of Kekule structure. Benzene has less heat of formation. It has less heat of formation. It has less heat of formation. And the fourth drawback of Kekule structure is inside the benzene ring we have alternate double and single bonds, right? Alternate double and single bonds are present, but it has equal carbon-carbon bond length. So it has equal carbon-carbon bond, equal carbon-carbon bonds. Students, these are the drawbacks of Kekule structures, right? Now the spectroscopic studies has, especially the X-ray analysis, it has shown that benzene is a regular flat planar hexagon. Benzene is a regular flat plane hexagon. Regular flat plane hexagon. All the 6 hydrogen atoms, they are coplanar with 6 carbon atoms. Yani all the carbon and the hydrogen atoms, they are lies at the same plane. The bond angles are between carbon, carbon and carbon. The bond angle is 120 degree. And the bond angle between carbon, carbon and hydrogen is also 120 degree. It means all the bond angles are of 120 degree. I hope this is clear to you, students.